One sort of general framework for multiplying Dirichlet series is through this language of Dirichlet convolutions. So the idea is you're going to define the Dirichlet convolution, denoted by an asterisk, of two functions f and g, evaluated at an integer n, to be equal to the sum d divides n of f of d times g of n over d. And you can see that, of course, it doesn't matter which is which, right? You're summing over all the same terms either way. So I mean, this is equal to the Dirichlet convolution of g and f at n. And the reason to think about Dirichlet convolutions is because they have they satisfy the following. So if you have a Dirichlet series of a Dirichlet convolution, then this ends up being the product, I'm going to say d goes from 1 to infinity of f of n over, it's going to be f of d over d to the s times some m from 1 to infinity of g of m to the s. So basically, if you have a product of Dirichlet series, then the coefficients of the resulting product are the Dirichlet convolution of the Dirichlet coefficients. And to see this, well, you can just multiply this out. This thing is equal to the sum d and m go each from 1 to infinity of 1 over md to the s times f of d g of m. And here you can write this as the sum n goes from 1 to infinity. So here you're making this change of variables, n equals md, and now you have a 1 over n to the s. And then for the numerator, you have to ask how many ways could md be equal to m? Well, the way to list all of them is to sum over d divides n of fd, and then here you have a g of n over d. So you could also view this as the change of variables, m equals n over d. And this is, of course, the Dirichlet convolution, f star g. So this can help you calculate things or manipulate Dirichlet series a little bit more quickly if you like this sort of framework. So for example, define the function 1 of n to just be 1 for all n. Then the Dirichlet convolution 1 star 1, this is going to be equal to the sum d divides n. Sorry, so this will be evaluated at n. And this is equal to, okay, well, 1 of d times 1 of n over d, which of course each of these terms is 1 because this function is always 1. So this is just equal to the number of integers d dividing n, positive integers, which is equal to sigma sub 0 of n. So now applying this property of Dirichlet convolutions, we can say that the sum the Dirichlet series n from 1 to infinity of divisor counting function at n for n to the s is equal to the sum 1 over, say, d to the s, d from 1 to infinity times the sum m from 1 to infinity of 1 over m to the s, which is the square of the Riemann zeta function. So previously, we figured this out using some Euler product, but you can also go about it this way if you prefer.